A hydroelectric power storage system, more commonly known as pumped storage hydropower, PSH, works like a giant rechargeable battery. It's a method of storing energy that helps to balance the electricity grid, especially as more intermittent renewable sources like solar and wind power are integrated. Here's a breakdown of how it works. 2 reservoirs. The system has 2 bodies of water at different elevations, an upper reservoir and a lower reservoir. The greater the height difference between them, the more energy the system can store. Reversible pump turbine. This is the core of the system. It's a single machine that can operate in 2 modes. Pumping mode. It acts as a pump, using electricity to move water from the lower reservoir to the upper one. Generation mode. It acts as a turbine, with the flowing water spinning it to generate electricity. Generator motor. This is connected to the pump turbine and also operates in 2 modes. Motor mode. It powers the pump to move the water uphill. Generator mode. It converts the rotational energy from the turbine into electricity. Storing energy. Charging the battery. During periods of low electricity demand, for example at night or on a windy, sunny day with excess power from solar and wind farms, the pumped storage plant draws electricity from the grid. This electricity powers the motor, which drives the pump turbine to move water from the lower reservoir to the upper reservoir. By moving the water uphill, the system stores energy in the form of gravitational potential energy. The water is essentially charged and ready to be used later, generating electricity, discharging the battery. When electricity demand is high, the system switches to generation mode. The water is released from the upper reservoir and flows downhill, due to gravity, through a pipe called a penstock. The force of the water spins the reversible pump turbine, which acts as a turbine. This spinning motion drives the generator, converting the potential energy of the water into kinetic energy, and finally into electricity that is fed back into the grid. Why it's a critical technology? Grid stability. PSH plants can quickly switch between pumping and generating modes, allowing them to rapidly respond to changes in electricity demand. This helps stabilize the grid and maintain a consistent frequency. Integration of renewables. It's an excellent way to store surplus electricity from intermittent sources like wind and solar, which often produce the most power when demand is low. The stored energy can then be released when the wind isn't blowing or the sun isn't shining. Long-duration storage. Pumped storage hydropower is a leading technology for long-duration energy storage, meaning it can provide power for hours or even days, which is crucial for a reliable energy grid. High efficiency. While some energy is lost in the process, PSH systems are highly efficient, typically operating at 70 to 80% efficiency in the complete cycle of pumping and